Hello and welcome to the MathLeague.org YouTube channel. My name is Joeli, and today we will be going over a problem from Team 12106, a high school test from 2021. This problem was number 8 on our team round. The problem reads, in how many ways can Ankit place a 1, 2, or 3 in each square of a 3x3 square grid, such that the sum of the numbers in each row and column is exactly 6? Two grids are considered different if the elements in any position differ, even if one can be rotated or reflected to produce the other, so there are 3 to the power of 9 possible grids. To start us off with this problem, we can see that there are 2 possible ways to fill each row or column so that the sum of the row or column is 6. Either all 3 of the squares in the row or column are 2, like this, or there's 1 square each with the numbers 1, 2, and 3, like this. So as you can see, this sums up to 6, that sums up to 6, and there are no other ways for 3 numbers out of the set 1, 2, 3 to sum up to 6. These are the only 2 options. You can check that yourself. So the trick to this problem is to realize that if we fill 2 of the rows so they sum to 6, and we make sure that we don't have 2 1s or 2 3s in the same column, which here we don't, we immediately have all the information we need to fill in the rest of the grid. We can fill the last square in each column so that each column sums to 6. So here we would put a 3 in the first column, we'd put a 2 in the second column, and we'd put a 1 in the third column. Now we have it so that each column sums up to 6. See, all 3 columns sum up to 6. So the sum of all 3 columns is 18, and the sum of all 3 columns is the same as the sum of all 9 squares in the grid. Since we know that the sum of the first row is 6, and the sum of the second row is 6, then the sum of the first 2 rows is 12, the sum of the whole grid is 18, so the sum of the third row must be the difference of that, or 6 as well. So this holds in our example, and it also holds for all other possible permutations of Ankit squares. So, now that we know how to reliably find unique ways of filling Ankit square, we can count how many possible configurations of the square there are with casework. The easiest way to do this casework is to focus on how many of the first 2 rows are made up entirely of 2s. There are 3 possible cases here that I'll draw out. The first one, this will be for the case where there are both of the top 2 rows are entirely filled with 2s. So we'll call this 2 rows. The second possible case is where there is exactly 1 row all full of 2s. This is going to be 1, 2 row. And there's the case where neither of the first 2 rows is filled entirely with 2s. We'll call this no 2 rows. Okay, so these are our 3 cases. Let's start with the case where both rows are made up entirely of 2s, so we can fill out this. And this is the easiest case, right? Because if both of the top 2 rows are filled with 2s, there aren't any different permutations we can make of the top 2 rows, and by necessity, the last row also has to be filled with 2s. So this gives us a grand total of 1 possible case inside, 1 possible permutation inside this case. Easy case, we're done. Let's move on to the case where there is 1 row made up entirely of 2s, and the other row is made up of 1 each of the numbers 1, 2, and 3. In that case, there are 2 choices for which row has only 2s in it. So that gives us 2, and for the example, I'll just go ahead and make that the top row. But it could have been either of the top 2 rows, right? There are 6 possible permutations of the row which has 1 of each number. So that gives us 6 permutations of that, and I'll just go ahead and do 1, 2, 3. And then we can fill out this example here. This would be a 3, this would be a 2, this would be a 1. This is another possible permutation of Ankit square. So we have 2 times 6, that gives us 12 possible permutations in this case. On to the case where there are no rows filled entirely with 2s. So now we don't have any rows to fill with 2s. We know that both of the first 2 rows each have 1 each of the numbers 1, 2, and 3. So once again, there are 6 possible permutations for this top row. We'll go ahead and just put 1, 2, 3 in our example. And then for the bottom row, we need to make sure that there is no column where there are 2 1s or 2 3s. If we do that, then we can't fill out the last row. So what we can do to find the possible permutations is we have 3 places to place the 2. Let's say the 2 in the middle row goes here. There's 3 options for that. And then once we place that 2, there's always going to be at least one of the 1 or the 3 that is not directly above the 2. So this 3 right here, we can't put the remaining 3 below it. So the 1 has to go here, and that means the 3 has to go here. So once we place this 2 in the middle row, we no longer have to worry about how to place the rest of the numbers. It's decided for us. So now that we have that filled out, we can fill out the rest of this example. This has to be a 3, this has to be a 1, this has to be a 2. There we go, that's a valid square. So we have a total of 6 times 3, or 18, possible permutations in this case. Adding these cases together, we have a total of 1 plus 12 plus 18, or 31 ways of filling out Ankit's square. This is our answer. We're done. Thank you very much for watching.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.